All right, problem number 3. We've got 3 points, negative 10, 0, 0, 5, and 10, 0. And these are the Cartesian coordinates of the vertices of a triangle. If x and y are integers, how many points, x, y, are in the interior of this triangular region? All right, well, I would recommend drawing a picture here to kind of get a handle on what we're dealing with, all right? So I'm going to draw a Cartesian coordinate system here. Try and draw it reasonably straight. As you've seen, I'm no good with this pen because it doesn't look very straight. But let's see. 5, 4, 3, 2, 1, 0. Okay, so our x-axis would be across here. And we have to go negative as well. So let's draw it coming out here too. Okay. All right, so we've got, let's put these points here on this coordinate system. So we're going to have to go over 10, 5, 6, 7, 8, 9, 10 in the negative direction. So that's negative 10 comma 0 right there. I'll draw a little point for you. And then over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 comma 0, and then up here, this is going to be 0 comma 5. Okay, right here. So this is our y-axis, and this is our x-axis. Where's my pen? Where did my pen go? There we go. All right. Okay, so that's our x-axis. So remember that the points are always listed x and y. So x is always first, just like it's listed here. So now that we have the points that define our triangle, let's take a look at what that looks like. Now, we only want the points that are in the interior of the triangle. All right, so we don't want the points on the edges. So let's define the boundaries of this triangle. Okay. So, and to do that, we want to know what specific points are on the edges of the triangle, so we can kind of eliminate those. So let's look at the slope of these lines, because we want to draw a line, connecting 0, 5 and 10, 0, and also negative 10, 0 and 0, 5. So let's look at the slope of those lines. All right, so the slope is just rise over run, okay, and which is just change in y over the change in x. Okay, so in going from this point, 0, 5, over to this point, 10, 0, it looks like we go down 5 and over 10. Okay, so we're going 5 in the negative direction and 10 in the positive direction. All right, so our slope is a negative 1/2. All right, so that means for every one that we go down, we go over 2. Okay, so let's draw in those points. So we go down 1 over 2. Okay, down 1 over 2. Down 1 over 2. Down 1 over 2. And down 1 over 2. Okay, so these are points that are going to be on the edges of the triangles. Okay, and same way over here. Let's look at the slope over here. So let's see, delta y over delta x. I was just noticing here I put delta y over delta y, and I meant to put delta y over delta x. So delta y over delta x, change in y over the change in x. So to go from this point 0, 5 to this point negative 10, 0, we essentially go down 5 and to the left by 10. Okay, and our reference direction is that this is positive in the x direction and this up is positive in the y direction. Okay, so we're going, if we're looking at going from this point down to this point, then we're going down and to the left, so it's a negative over negative. But we could think of it as going from negative 10 up to negative 10, 0 up to 0, 5, and then we'd be going to the right by 10 and up by 5. Okay, so in that case, we're going up 5 and over 10. So you can either think of it as going down and to the left or up and to the right. Okay, so either way. But the slope is positive 1/2. So that means for every time we go up 1, we go over 2. Okay, in the positive direction. So that's up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And then finally up 1 over 2. So you can see now the triangle. And I could dot those, I could draw some dotted lines through those, past those points. Okay. And then you can see the edges of the triangle. But we're only concerned with the points that are in the interior of this triangle. Okay, we don't want to concern ourselves with the points that are on the borders of the triangle. So that includes anything that lies on these lines, which we've marked, okay, here, and there's these along these 2 lines, and then also along the axis. We're not worried about those because those are the boundaries of the triangle. So in the interior, I could actually mark these here. We have a point here. Now I've got a nice background here with a grid on it, so it's easy to work with. I mean, you might want to put label these points so you know what you're dealing with. So when you go down 1 and over 2, that's gonna put you at what, 2, 4, okay, and then down 1 and over 2 is gonna put you at what? It's gonna put you at 4, 3, all right, and down 1 and over 2 is 6, 2, and this is gonna put you at what, 8, 1, and then finally 10, 0. And you could do the same thing over here, going down 1 over 2. So this brings you over to -2, 4. Okay, for this point here. And then again, down 1 over 2. So that's going to put you at what, -4, 3. And -6, 2, and -8, 1. Okay, so that just defines the boundaries. And I'm not going to worry about labeling all these points along the axis. But those are the points we don't want to include. All right, so let's mark the points in the interior. So we're looking at, this is symmetrical too, so I can really just look at half of it and then double it. So let's mark these points here. Oops, I forgot one up here. Okay, so we can then look at the rows. We have 1 in this row, we have 3, we have 5, oops, 3 plus 5, and then we have 7, okay? Alright, if you add those up, that's pretty easy to see. You get 3 and 7 is 10, plus 1 and 5 is 6, so you have 16 points. And that's just the points over here in this half, okay? And it doesn't include the points here on the axis, okay? Because this is the axis of symmetry, so we'll add that in later. But you can see that if I took all of these points over here, it's going to be the same number of points over here, right? 1 plus 3 plus 5 plus 7. So this, you have another 16 points here. So you have 16 points here, 16 points there, and then you have 4 running. Alright, the cat just walked across my computer and messed me up here, but as I was saying, you have 16 points on the left and 16 points on the right, and then you have 4 running down the axis of symmetry. Okay, so you get 16 plus 16 plus 4, 32 plus 4, that's 36 points in the interior of this triangle. Okay? So, so that's your answer. It's 36